Hi again. This is still exercise 2F. It's question 5. My special request. This is the part C, finding the standard deviation of x. And we've got here the formula. This is the sigma sign of standard deviation for x. And I'm using this version of the formula. So there is another one, as well as the calculator, which is just the square root of the sum of all of the differences. So we'd have to work out each individual difference, x minus x bar from the average, multiply it by the frequency, and then divide by the number we have in total. So this formula would take a lot of ploughing through the data, whereas this one, often it's more straightforward. Here we've worked out the mean already, and all we have to do is find the x squareds and put those in. It's even quicker on the calculator, but with this question, I'm going to work it out by working out the standard deviation for y instead. So we're going to replace all of these with y, because these new numbers are going to give us a slightly easier to work with result, even though it's going to take a bit of calculation. So you'll notice the thing we have in there, we know y bar, the mean of y. What we don't know is y squared. So we need yet another row. So it's worth using a bit of space. I want y squared. So I could have done x squared, I could have worked entirely with x. But I'm going to show you how simple it is if you can use the coded data. Very simple transformation to get it back. So y squared is literally this number squared. So, well, 1 squared is 1. 1.1 becomes 1.21, 1.44, 1.69, and 1.96, I think. So we've got these y squareds, and notice the order that we do things in. We need to square it, but those squares still need to be weighted by the frequency. So we're still using this top row of the frequencies to work out y squared f. The frequency isn't squared, so we need to multiply this number by this one. The nice thing is these are quite small numbers, but they're still going to be a little bit fiddly. We've got 3 times 1 here is 3. Calculator's coming out. 12 times 1.21 is 14.52, and so on and so forth. 40 times 1.44, 57.6. So we're working our way along. They're not so different from these ones because the y values are all around 1. That's just times 10, so 16.9, and 1.96 times 5. So this thing in here, this sigma of y squared f, is now the thing that's going to pop out at the end of this column. So if we add all of those together, we should get this thing, sigma y squared f. So this bit in here. So if I add those together, plus 16.9 plus 57.6, you can see this does take a while to do manually. So it's only if they need you to show your working, you have to do all this processing. Wonderfully, we've got things like Excel spreadsheets, which should be on the syllabus instead of using the calculator. Calculator does something similar. This is 101.82. So I now have all the little bits that I need for this equation, I've got the square root of 101.82, which is the sum of all these y squared f's that I've had to do so much manipulating for. N, well, that was the sum of the frequencies, so that's still 70. And subtracting y squared, so that thing squared, 1.2028. Now, the more accurate you can get this number, the better. So I'm going to try and put it all in. So divide that by 70, subtract the 1.202857,143. Trying to get the whole thing as accurate as possible, squared. So I've got something under there, and now square rooting it, I get my calculator 0.08778 blah blah blah. Okay, so we've got a standard deviation for y. This is y's standard deviation, and it's quite a small number, so it's not, remember this is a measure of its spread, so it's not very spread out, but you wouldn't expect it to be because we've manipulated the numbers to be quite close together. So the last bit is just to convert that into a value for the standard deviation for x. And remember, what's key is that this is the spread of it. It doesn't matter if these are really big numbers or really small numbers. So the shift doesn't make any difference. This -1 up here doesn't make any difference to how spread out they are. They could be equally spread out around 100 or around 20. So all we need to do is use this scale factor that we've got there and say that, well, x would be divided by 20 to give us sigma y. So we're expecting sigma y to be 20 times bigger. So that pin doesn't work very well, does it? So that means and I've handily left sigma y on my calculator, so I can just multiply by 20 and I get 1.7557, something like that. It's rounded actually. So it's slightly bigger when we multiply it by 20, and that's the standard deviation of these original midpoints for this data. That's how spread out this data is. So it's quite a nifty little measure. But like I say, we can work with the coded data or the original data. I'm just going to show you quickly how that looks on the calculator. It is very quick, and I advise you to cheat whenever you are allowed to. So if I put this up, so it's got a bit of light on it. When you, if I go back to normal, when you press this button here, you should get this selection here. We should by now know we're looking at this little bar chart thing here, number 6. You can also cursor down to it and find it's number 6, press the 6. And what we've got is a list then. We just have one variable. You'll notice this is where you can solve, you can put polynomials in as well. But we're going for number one variable. And you should get a little frequency chart there. And you can literally put in your midpoints with values on the left-hand column, press equals after each one, and you can use the cursor key to get across into the frequencies column. Put your frequency in there. And if we put this data in, so we've got a value of 21, 23, 25 and 27 and 29 equals, so remember equals after each one. Frequency will come up as 1 unless you change it. So I've just got 1s in there at the moment. I'm sure you can see that. And then we're going to put in the frequency. So next to the 21, we've got 3 equals, next one is 12 equals, 40 equals, 10 equals 5 equals. All the data's in. Then it gets a bit weird. What you have to do is clear the screen. So you actually press AC, the AC button. And we've got statistics, 1 variable. So it tells you it's still in that mode, so the data's saved. And then it's the option button that gives you what you want to know. So we're going to go for line 2, which is variable calc. That's going to give us all of the data we want. Now this is tiny, so good luck with this, depending on how your eyes are. But you might be able to see there on the top row, I'll put it here, we've got some data. We have X bar on the top, 25 point. Well, I've got 057 on the board. What have we got on the screen? Yep, it's about the same. We've got the sum of all the x's. So if we did want this sum of all the x's, we've got it. We've got the sum of x squared. So if we'd gone down that route, instead of doing y squared, if we'd done x squared, we could have had the sum of them. Again, that wasn't very useful because it's not been weighted by the frequencies. So in this case, not very useful. Then we've got sigma squared. Now, that says sigma squared x. Don't worry about that. That's sigma squared. The x is just telling you that's the variable. It's like my little x at the bottom here, sub x. So that is sigma squared, which is the variance. That's what it's called. And then we've got sigma x on the second to last row. That is sigma x. So that is, yep, that's the same, 1.75569. That's the same as my by hand calculations gave me. And the bottom one, we won't worry about that one just yet. So you can get all that data out. I think it's even, that one doesn't have the sum of the, oh yeah, there's more. If you press the down arrow, we get a whole selection more. We get the total number of frequencies. You've got n there. Second one is 70. We have got, what's the other one? We've got the quartiles in there. Quartile 1 and quartile 3. So this is really good for checking your answers and or cheating. It's not really cheating. It's just like putting it into a spreadsheet on Excel and it just knows what you want to know. It's just remembering which buttons do what. So the key was you put in all that data on 6, clear the screen with AC, and then it's so AC, and then it's the option button, and I think it was number 2, data calculation, variable calculation. So do practice with that, and just be careful using this formula. Make sure if you're going to do it by hand, that you do square all your y values before you weight them with the frequencies, before you multiply them by the frequencies. Okay, that's enough of me. Hope that made some sense. Feel free to jump about in the video if you need to see something again. All the best, bye.